I wanted to quickly go over the projectile motion lab. For this lab, you're going to be using the simulation, and it's pretty straightforward, the simulation. For the first part here, with no air drag, as it says in the directions, you're going to click on the lab icon, which is way over here, and you got to click twice on it to open it up. And you can see there's a cannon, and there's all sorts of sliders over here, various tools. And the red button there, that's your launch button. So, you hit that and it's going to launch. Okay. And in this first part here, it talks about you can use the range finder tool. That's this tool up here. That's this tool right here, which you can put, and you can see these little dots that are along the trajectory. And if you put the rangefinder tool on them, it tells you the data for that dot. So this was 2.8 seconds after launch. At this point, it has moved 8.75 meters. It's the X displacement is 8.75 meters from where it was launched, and it's 11.18 meters above where it was launched. And so this first part, pretty straightforward. You're going to play with it to figure out the angle that maximizes the range and the angle that maximizes the peak height. And then there's some calculations here for number 5 and number 6, where you're going to use for 5, you're using the maximum height formula to find the angle in order to get the various values there. And for number 6, you're using the range formula. Now, in the second part, this is where you're actually dealing with air drag. First, you got to essentially do a force diagram. But then when you get to number 2, it says to come up with an expression for the net force for the situation described above, which is a ball released from rest. And you need to enter in essentially the forces. So if you do that and you type in here, you can see this pad on the right here, this fizz pad. You're going to be making use of that. So let's pretend, I'm just going to make up some formulas, that you had the normal force. So it'd be capital F. Because you want to use, I need to stress here, you want to use the right symbols. And the symbols for the various forces are written up here in the first part where it says gravity is F sub G, air drag is F sub D. This is the notation you have to use here in this in number 2. So F, now I want a subscript, and that's, you can see the subscript button over here. I'm going to press it. There we go. And capital N. Then I would do capital N. And now I'm using my tablet here, so I just push on the screen to get off of that. You can't push it again. If I keep pushing the subscript button, it would just make a subscript of the subscript, and that's obviously not what I want. But then I might do something, maybe this is plus. I'm just making up some values here. Maybe it's plus kinetic friction. And so then this is how I would enter that again. I do the subscript and lowercase k. And that's all there would be to it. You're just putting in the values and then you're submitting. And there's a couple problems that are going to use the fizz pad. The very next one, number 3, uses it. For number 3, this is for solving for the terminal velocity, and the formula that you need is given in the very beginning of number 3. It's a second sentence where it says specifically the drag force, which is F sub D, equals D times V squared. So it's giving you that formula there for air drag, and you're supposed to go through and solve for what D is, and you're solving symbolically. You're going to come down here. It takes you through what to do, where you're launching cannonball straight up. And so just to show you what exactly is going on here, so this is the drag unit, and you're launching it straight up, and you've picked this up to 15 meters, and I think the drag coefficient is supposed to be at 1, diameter is at 1, the mass is at 1, there we go. And you launch it, and it just barely goes up, and then it comes down. And it's going to reach terminal velocity, which is the velocity it has when the net force on it is 0, as it's moving through the air. And what it's asking you for is you're going to use the range finder to get some values to fill in the table, and once at H1, let me go down and read exactly what it says here. So The cannonball should have reached terminal velocity during the downward part of its trajectory. To determine the terminal velocity, use the rangefinder tool to get the heights of dots 1 and 2, T1 and 2. So, okay, so the times are listed here, 4.8 and 3.4. So you got to get the heights, and you get that by using this rangefinder tool. You put this up here, and it says, can I get it to stay? There we go. There's the time, and it's telling me the height. So you'd record those heights of your 2 points that you're asked to put in for. And the thing is, why do we want those heights? Because then we can get the velocity. We'll know from the height data and the time data. Well, from the height data, you can get the distance that it traveled between the 2 points, and then the time data, how long it took to go between those 2 points. You know, distance over time is speed, so you can calculate the terminal velocity. And to get to D, you can just go up to your solution for D that you got, plug in the values to go ahead and calculate what D should be. Then, as it says here, you're changing the mass and using the D you just calculated to predict what the terminal velocity should be for, in this case, for mine it's 2 kilograms. So I would go through the process of predicting what the terminal velocity would be for a 2 kilogram mass that has all the same attributes. And then do it again for that 2 kilogram to see how well it matches up. Then there's a couple more problems here, and here where you're doing essentially the force diagram, that's number 10. You're doing the force diagram for a projectile that's fired up and to the right. So it has a parabolic trajectory, and you're looking at the peak, and you're talking about what forces are acting on in what direction. And then you've got to come up with, you got to do Newton's second law for that situation, so get the net force and for both of these. And again, this is using the symbolic, so the phys pad is going to be used again here. And then you're going to go through and solve for the x acceleration using the formulas you came up with in 11. You'll use those to solve for the x and y accelerations. And you can see it says your answer should be in terms of m, g, capital D, and v. Those should be the only letters that are in there. You might have some numbers, but you won't have any other letters. Those are letters that your answer should be expressed in. Obviously, if you have any questions, don't hesitate to contact me, but I do hope this clears things up.